Hi and welcome back. Today we're going to go over Valet key architectures. So this is a technique where we can offload some of the work from the main architecture of applications. It means we don't have to scale the solution quite as large. It means most of the traffic isn't going through the solution, which means microservices can be smaller, fewer resources, cheaper. But it also has some fairly good security implications, which means if you've got external parties downloading data from you, then the data that they're downloading isn't going via your network, which means there's no escalation path for them to get into your network. It means if they were to somehow compromise something, they get access to a very small sandbox. So there's all kinds of benefits to this architecture. It's not very widely known. It also uses SAS tokens. So if you know me on LinkedIn, I recently ran a survey to see whether people trusted SAS tokens on storage accounts, whether people use SAS tokens on storage accounts. And the majority of people said, no, they're not secure. My security team won't let me. There are more secure ways. A lot of people thought that Azure AD was a more secure mechanism. It's technically not. Azure AD allows manageability of authorization and authentication, but it isn't more secure. And that's a very important distinction to be making, because sometimes you need the ability to support users that are not in your Azure AD, that are not in a trusted third-party Azure AD. You might want to support just members of the public logging in and downloading data or uploading data. And in these scenarios, you're not going to sit there and have a provisioning process to create accounts for them and those kinds of things. And you don't want always anonymous access. You don't want to just open the floodgates and let anybody in. So sometimes these things are necessary, sometimes they are required. And think of this a little bit like the one-time passcodes from your bank that you're probably getting these days. They're mandated in most territories now, where you try to spend some money or you try to log in, your bank will then send a text message with a code in. You type the code in, they know that it's you because you received the code on a device that you've told them that you trust. But that code is only valid for seconds or a couple of minutes. So even if somebody else were to get that code, they would have very short-lived ability to be able to actually break into your bank account. And the same applies here. So we're only giving access to a very small amount of data for a very small amount of time. Usually there's no access to the system at all, whereas in most situations where I see directories used, actually permanent access is given to the lake, which means that you get bad actor attacks that have access. They can then download any data that they want to. In this scenario, they have to log in, they have to click download, they have to get a token, and they have to get that data. So there are a lot of advantages to this. It's worth being familiar with these techniques. There are loads of scenarios where you would use this. It's not just the ones that we'll discuss today. So make yourself familiar. It's worth mentioning this is a pattern called Valet key. Valet, like the car valets. This is documented on the Azure documentation website. So please go there if you want full information, if you want to see the official Microsoft kind of a thing. I know that AWS and Google will have something very, very similar. I happen to have used the Microsoft one here just because I work there. So I'm going to go through the architecture quickly, and then we'll talk about sort of use cases and scenarios. So here on the screen is the architecture at a high level. I copied this diagram from the documentation. I recreated my own rather than just using the material, but it's the same diagram. So what happens is you've got a user that's sitting out somewhere. This does also work if it's within your network, but largely this scenario is for external access, in my view at least. So the user logs into the application, so they've authorized against the application. We know who that user is. We know what they're entitled to. So the user requests something through the application, and this application is a very, very small footprint web service probably, and that application knows who the user is, and it has some kind of a list. It could be a database of what that user is entitled to. So it looks up, is that user entitled to that thing? Yes. Okay, we'll generate a token against the storage service. And this is using the management layer of Azure. It's not using the consumption layer. It's not interacting with the storage account itself. It's going via management to call the API and say, generate me a token. And this token can be revoked. It is definitely going to be time boxed, so you want to set the time to a reasonable amount of time for the user to access that thing. If the user doesn't access it within that time limit, they can go back into the app and request again. So you want it long enough that the user, it's kind of convenient within a session. So let's say if you're downloading a small file like a MP3 of 5 megs, let's say, it would be reasonable to assume that a user could download that in 20 minutes. So we would set that token at 20 minutes. If you're downloading a PDF file that's maybe, 50K, and it's just a report, then you might set that much smaller because the user is already in the solution clicking the download button. So it's reasonable to assume within 5 minutes they're going to have it. And if somebody were to try and break that token, they would already have to have compromised the user's PC in order to get that token. But not only that, they'd have to be sitting there when the user logs in and clicks the button, and they would only get access to the things the user is entitled to. So it's very, very locked down. There's not much kind of danger here of getting compromised or of losing data. I wouldn't put your very, very important data in a solution like this. I certainly wouldn't use it for PII, but for general data sharing, it's kind of fine, and it can even be kind of relatively sensitive company data, because the amount that you would lose would be tiny. The actual risk of losing it is tiny. And to kind of quote another YouTube channel out there, it's super good enough. You don't need this to be completely uncrackable. You need it to be secure enough that in normal circumstances you're not going to lose data. If somebody isn't completely determined to get at it. And realistically, if somebody is that determined, they're probably on your corporate network. So this has some benefits because the storage is not on your corporate network, which means that actually if somebody compromises your corporate network, there is no way to this solution because it's just not on your corporate network. So on we go then. So the token gets sent back to the user, and this can either be the actual token. If the user is sitting inside an application, that token can just live within the app, or it can just be a link to a file with the token already in it. The user never needs to really see that token, and you can use browser redirects and stuff. So the user can then access the storage account directly. This is over the internet, and they will then download a file using that token, effectively one-time access to one file. The documentation doesn't make it clear, but SAS tokens on storage accounts in Azure can be down to the file level. You have to use the API. A lot of people get confused about this because in the graphical interface on the Azure portal, you can only go down to the container level, I think. And people kind of think that's not fine-grained enough. But actually, you can, with this solution, you can actually push a file to the storage, and then you can set up a SAS token. They can download it, and you can actually monitor and see once that file is downloaded. We could leave it 5 minutes for the download to complete, and then we can actually delete the file as well. So in theory, this storage account out on the internet will be empty most of the time. And then only when we've got something for somebody to download, we can then load a file in there, give them access, they get access, download the file, and then we delete what was there. So in the case of data platforms, why is this useful? Why am I talking about it, and why are you listening to me prattle on about SAS tokens? So there's a really common scenario in data where people want to share information with third parties, and quite often you will have your data lake, and then as soon as people start talking about data sharing, the assumption is often, oh, well, then we've got the third party, and they're just going to share access through the data lake. We might use Azure Data Share to give them access to that lake. This fails for a number of reasons. Firstly, let's take the scenario of retail where this is the retailer over on the left, and this is one of their suppliers over on the right. Now, if we open up the data lake, effectively we're giving them access to all of our data. And we never want to do that, or very, very rarely would we want to share all of the data, because this is one supplier. There are hundreds or thousands of suppliers, and you don't want them seeing each other's data generally, or they don't want other people to see their data, and because of that, they expect only to see their own. So then we end up seeing people doing really complicated folder structures and doing data shares individually for the folders, for the files, and then we get really complicated kind of permission schemas and stuff like that, and then the suppliers have to have accounts provisioned against the Azure AD, and then we end up with trust things, and the cost of these solutions really escalates when you do that kind of thing, because you end up with a lot of operational cost. You have to have a process to onboard them. You have to have a process to connect them to the network and stuff like that. So what we can do instead is, and we're going to remove the data lake for a moment because we'll make it slightly simpler. And we'll assume that Synapse is the back end of this. There's a data warehouse that's already full of data, etc. So we're then going to set up an app. And I don't have demo code of this yet. I'm thinking of writing it. Pop something in the comments if you'd love to see that. It would be quite a big project, so that's why I'm kind of explaining it first and seeing if you guys are interested to see what's kind of worthwhile me creating, because this could take months to set up a full demo. So we've still got our supplier out there, and this supplier can log into a web app online, so they don't need access to the corporate network. They don't need access to our AAD. We don't need to provision them an account. It can be self-service, and we can use Azure B2C for this. We can use Azure B2B if we wanted to. But this allows them to bring their own identity. So even your tiny suppliers that might be a little farmhouse selling honey or something would be able to use this solution. The web app is then capable of running queries against the Synapse instance. So obviously we need some way of mechanism to control this, which will be the logic of the application to say we can tie that person to this aspect of the data. So each supplier can only see their own or whatever, or a subset of their own. And so the web app is able to run a query against the database and return that data. But we don't necessarily want this application to pass all of that data through itself and out to the user and stuff. So what we can do is set up a storage account, and then we can write the results of the query out to the storage account. At the same time, the web app is going to go and get a token, and it can return a download link to the user, or even better, it will craft a query so a user clicks on a link to say, I'd like this data now, please. The app can then generate the token, form a URL, and then just redirect the user's browser to the file. And the user's browser then goes direct to storage and downloads that file. The interesting thing about this as well is that it can be completely asynchronous. So you can have a scheduled job that's going to go and take the Synapse data and write out to storage. And this could be happening once a day. And that means that the files are already there. We've also got a cleanup mechanism. So each day when we write a new one, we're deleting the old stuff. So there's very little information actually out in that storage account. It could be just today's data. It could be the last week's data. Whatever scheme that you come up with to protect the data the way that you want to. And then when the user logs into the app, that's the point that the security token gets generated. So day to day, nobody has access to this storage. There are just a bunch of files with zero access to them. And it's a subset of our full data. So the Synapse instance back here has all of our data for the last 5 years. It's got all of the suppliers represented in there, and we don't want to just give access to that full data set. So this allows us to run subsets of queries. You can actually also be proactive with this, so you don't have to get the user to define the query. You could just have queries running as part of your ingest routine, so you don't need Synapse as part of this. You can actually have your lake over here, and you can then have a Spark job or an ADF job, outputting files each day for every vendor, putting them in some storage, ready. And the reason why this is good is because you don't need to have a large cluster sitting there waiting for queries. And in terms of that's wasteful, why are we running it every day on every single thing? Well, actually, most of the cost here is the spin up time of a cluster. So the more work we can get that to do while it's on, the better. And waiting for ad hoc queries means that we probably need the same size cluster running all of the time, waiting in case a query comes. So the actual trade-off is I'm only going to run my cluster for maybe 4 hours, and that may cost hundreds or thousands of dollars of consumption, but it means that I'm saving tens of thousands of dollars of consumption because then I switch it off. And that's the important thing with cloud architecture, is the then I switch it off part of the architecture. So this runs temporarily as part of an ADF pipeline or something like that, dumps the files, and then when we log into the storage, we just say, I would like access to that file. And something goes off and checks, okay, yep, you've got access. I'm going to give you a token to get that for the next 5 minutes. Here's the token, redirect the browser, download the file, and then we're kind of done. So through all of this web app up here, very, very, very small. This literally just has to be a user interface and a little bit of logic in the back end. And most of this time, this Spark cluster is offline, or this ADF is offline. Most of the time, the lake is sitting dormant. So we're not really spending any money on this solution. It can be very cheap and extremely scalable. And because this is outside of the network, you're not running through any security appliances or things like that. So you're reducing cost there. You'll obviously monitor the logs of this storage. And if you see the same IP address requesting multiple files, you could shut that down and investigate because it's probably not normal behavior. If you see a sudden ramping up of the number of tokens that are generated, again, that would be cause for concern. But you don't need to run it through a WAF or any security appliance like that. There's absolutely no benefit to watching the network traffic here. All that's happening is people are downloading a file, and we already know that from the logs, so we don't need to watch that happening. And if there was a compromise here, it's not one that we're realistically going to catch. And so just watching the logs is probably the better way of doing it. The platform itself has DDoS protection built in, so actually we don't even need to protect against that. So the public interface of the storage is super good enough. It's the term I used earlier from the How Not To YouTube channel, if anyone's familiar with that. And I think it's a great way of looking at the world, that we should make things as secure as they need to be. But there comes a point where you have to stop, get some work done, and get a solution implemented. And that's why it's good to know these kinds of patterns. So hopefully that's been useful to you. It's opened your eyes to a architecture that you may not have seen before. It's hopefully explained a bit about SAS tokens, where they can be much more useful than directly integrated identity. And hopefully this is a pattern that you can use in your data platforms for sharing data outside of the walls. Any questions, hit me up in the comments below. I'm quite happy to chat. You'll see from my other videos, I usually answer comments within a few hours. Most of them get answered within a week. And more than happy to discuss this stuff. I really enjoy chatting to the community and kind of helping you guys out. So if you want to see more of this, please hit like on the video to show me that you enjoyed this kind of content. Hit subscribe if you want to see things popping up in your feed from the channel when I create new videos. It's completely free. It just means that you're building your own TV channel with your own interests. But it also kind of helps with the algorithm knowing that people actually do want to watch this stuff, because data is a niche within a niche within a niche. So the algorithm doesn't usually push this content on people. So thanks very much for watching, and I'll see you next time.